First, I want to ask you, excuse me, my English is very hard, so if you didn't understand anything, please manifest yourself. Well, I am QMX. Let's forget about it. I am QMX. No one knows me by Douglas. That's okay. I work basically all my free time on open source. I'm kind of addicted. I recommend this service to anyone that wants to evolve on the career or to learn tons of things, to get deep involved on open source stuff. I contribute to the JRuby project with this kind of stuff, like the class generation and whatever. And I'm a Java developer, so you can throw the tomatoes. The question is, why to build a new JavaScript implementation? So Rhino is slow, okay, but it's complete. It's pretty complete. It even has the E4X extensions. Like, no, I don't think that it was the first one, if I believe. And the idea is, why build a new implementation? Just the geek appeal. Just because it's fun to write some kind of this kind of software. So the main reason was it's because it's fun. In all open source projects, I go and extend it to my life. If I don't have fun with something, there's something wrong, definitely. So I want to have some fun. And my main motivation was because of this. I love open source. So I started to find some project to experiment with the invokedynamic stuff, and I think you probably aren't able to read anything. I'm stuck, okay. This is the commit log from Rhino's open source release, circa 99. So Rhino is nearly a very, very elder project. When Rhino was released, we got nearly the release of Java 2. That's slow, it's painfully slow. This JVM, it was on the beginning, it has very cool features, very interesting ideas, so people were more worried about the write once, run anywhere stuff, but it was slow. So we can say that Rhino developers are the miracle guys. They made amazing things to make this happen, like optimizing things by hand, bypassing all the limitations of this JVM to get some performance, at least some decent performance. So I ask you, let's clap for the Rhino guys. They made an awesome job. Without tools, without everything they could have today. So, my main idea, I don't want to bash Rhino project or not dismiss, they were amazing. The problem is, we are talking about 10 years, more than 10 years of software development. And all softwares, all open source software or commercial software, whatever, suffers from bit rot. Usually, time passes and people, oh, I will refactor this tomorrow, or this tomorrow is about 2 years after that, but that's out of question. So, Java 7 came with lots of new features, very cool stuff. I like JavaScript, so why not try to put invokedynamic and the cool stuff of Java 7, the support for dynamic language support inside of Rhino. Well, when they did Rhino, they didn't have the tools we have today. So the majority of things that were hard, like generating Java bytecode or generating deep low-level stuff, were done by themselves. Basically they were generating bytes and bits and all that stuff directly to files to emulate what the Java matching would expect. That's pretty steep to learn. So I managed to run, to understand the code base, but I feel frustrated because, well, we have better tools today. And that's the main motivation. I wanted to have fun, I wanted to contribute to open source, learn new stuff. So that's the challenge. I want to build a new implementation. But why not? So I took the challenge and made 3 premises for my development. I assumed that at first I wanted to have fun. On the second, I wanted to learn something new. That took me a hell lot of work. And the best of all, if possible, have beautiful codes. That makes things easier for new people. But having beautiful codes on compilers usually are things that some guys with long beards and stuff like that do on the dungeons or something like that. So, yes, we can have beautiful code, or at least we can try hard to have it. So, I started to try to write a friendlier compiler. Why not again? We have the JVM. The JVM is a very beautiful piece of software. Okay, it's damn hard. It's damn complicated. They did lots and lots and lots of optimizations. This means that they optimized the JVM for one language that begins with J and not JavaScript, unfortunately. So they make some structure to make the language run and run fast. We're talking about how the invocation of code works on the JVM. When you need to make an invocation, the JVM on the compile time needs to be aware of what types are involved. So we're talking about static typing that usually who works with dynamic language don't like it. Majority of people. I like both, but anyways. The idea is the JVM needs to know the type that's calling and the type that will be called. So this makes the JVM aware of types and opens the possibility of very specific and powerful optimizations. When you have object orientation, you have some invocations on instances or like objects, by the way. You need to know the object that contains the method. Like, let's imagine that C is a function, and I need to know where this function are. I just can't invoke it alone. I have another case on Java that we try to implement some kinds of duck typing, but it's nearly impossible to have it, unfortunately, because of the static typing. So when I want to have polymorphism, I need to use some stuff like interfaces that this guy swear that he's B, but on the reality, he's just implementing Twitter open. So the truth is that he is implementing a contract. Okay, that's pretty full of boilerplates. Let's see what we have new. On the GDK 7, we have dynamic invocation. What does this mean? I don't know this D type. It's whatever. I don't have any idea of what type is that. When I want to make the invocation of the C function, the premise of the JVM is that we need to know both sides of the conversation, like we are talking about objects passing messages. So when I try to make this invocation, it won't even compile. So the invokedynamic instruction and all the JVM support means that now I can have an intermediate partner on this conversation that knows how to find the target method that I want. So when I made this invocation, after passing with this guy, I'm able to make a direct invocation without knowing the other side. That's huge. That's huge because we can remove tons of codes that were used before just to make this invocation happen. So we have on JRuby, like for example, lots of invocators, classes that we generate on the fly just to glue some Ruby code with some Java code and begin passing messages between them. That's pretty huge. It's about 3,000 files. With invokedynamic, we can remove everything. That's great. But unfortunately, there is a catch. This is VM only support. So I don't have like new invoke dynamic on the Java code. We know that Java language sucks. It's a fact. We can do pretty awesome things with it. We can even do awesome pretty things with VB. Yeah? So the idea is that even if Java language sucks, we can make it work, like as we have VM support. The true language of the JVM is bytecode. That's binary stuff, hard stuff, and pretty complicated to do. This is an excerpt of the bytecode. Basically, it's binary data. I don't want to do that. The Rhino guys go very closer to that. They have some helper classes that generates that kind of stuff. So we have better tools now. I want beautiful code. I don't want to mess with binary data. So I started to think about abstraction. How could I abstract the bytecode generation that it could be better? So we begin to see the enterprise labels that people gave. But anyways, I made an internal language inside JVM to make the bytecode generation a little bit friendlier. That's JavaScript. It's another project that makes things a little bit easier. Let's take, for example, this JavaScript code. I'm not making a compiler yet. I'm just making what I want to do. I want to print something. In bytecode, I will do that. Okay, forget it. When I go to the high level of disassembled bytecode, I will get some instructions, like define a constant, find the system out. People that ever studied Java knows this. I get the out variable on the out field on the system, then I turn them on the stack and make the invocation to the print method. That's pretty ugly, forget it. I have a better form to do that. I want to use, as I have a static language, I want to use what I have on the IDEs and that stuff to make my life easier. So I did a DSL. This is the same code, the code that generates that ugly bytecode. So you can have a new code block, and all the constructs on the dyn.js use these code blocks as building blocks. So if you have a big problem, you split it in smaller parts, and this makes things a lot easier. So I don't want you, as JavaScript developers, to understand this. Just compare. That's a hell lot easier to read, and makes it easier to explain what's happening under the hood. So let's see one example for the real world. And this time we're talking about the dyn.js AOT compiler ahead of time. So I have this code, that's stupid JavaScript code. What I need to do to make this work, I need to define this decimal literal. I need to retrieve the current scope. We have a global scope on JavaScript. I don't like it. Most of people don't like to, but anyways, there is it. And I need to assign this new object that I just created, or in this case, a primitive type, to this scope. So I define the literal with this small amount of code. Then I find and fetch my current scope. And finally, I guard the variable, the value, on this scope. 3 snippets of code. It's complicated, I know. But at the same time, I have comments, and I have very small splitted parts. So we can start talking. And that's it. No. There's more. We did, I don't know if you will be able to read, but there is an invoke dynamic instruction with a string passing, like dyn.js scope define. Where does this thing go? When I make this invocation, I'm sending to the JVM an instruction to do that stuff. And that stuff has a signature. I told that it returns nothing it receives a scope and a string and a dynatom. It's the common type for all the objects and primitive types on the JavaScript, on the dyn.js. So this code will go to this framework that was released on the JVM Language Summit, a very deeply technical congress that happened. I don't know why, I wasn't there. So this framework is meant to make dynamic link possible. So I can have compiling phase, like generating my bytecode. I don't have the type information, but I can make the linking of some dynamic codes with some static codes at runtime. So I get built-in type conversion for free. I just need to tell the framework, like, I have a primitive like string. When we try to call some method on that primitive string, it gets auto-boxed. Oh, I made it wrong. Okay. It's even a number, it's the same thing. I will take this primitive, do a new number, and then invoke the method, or something like that. I just can convert the types. Given two classes, I can compare it and make all the conversion under the hood. So on the invocation path, I don't need to worry about that. If the type is even a subclass of the number or whatever, the framework will take care for me. I have another thing for free. Dyn.link comes with a monomorphic inline. What the hell is that? So, the idea is that do you remember? JS is dynamic. We like it. So, but we need to know the types. How do we get from A to C? We need the... Problems. When we want to go to C, we issue an instruction, like scope define. And we receive this call, scope define, as this linker. The code inside the code base, let's not worry about that. But instead of needing to have now the types beforehand, I can do this linking with an if, ugly if code. That apparently sucks. But the truth is that we are not making the invocation by ourselves. We are just passing pointers to the JVM. Do you remember these pointers? That's awesome. The C pointers, the pointers for functions and that stuff. Now on the JVM, because of Java 7, we have pointers to methods. They are called method handles. I don't never know how to translate this to Portuguese. Thank God. So I need to find a target for my invocation. Then I want this target. I have a method on the scope class named define that receives the name of the variable and whatever that I want to put on my scope. So I get the pointer with this word API. I tell what the signature I want to find, what's the name of the method, where is that method, if I know this class, if I know we have some tricks to even not pass this. And this will return me just the pointer. I won't make the invocation. The framework will make the invocation for me. So the JVM do all the hard work for us. In the sense that I don't need to worry about if my code will be slow. When I make these pointers, the JVM looks it as if he knows that he used the type beforehand. And this invocation will be potentiable, unlineable. Because of this, we have a new idea lying around. We have more languages on the JVM, like Ruby and JRuby, Jython. We have Rhino. Rhino itself is walking slowly into invokedynamic. And we have now the dyn.js. The idea is that they are trying to agree on a common protocol for all object-oriented languages, so that I can make an invocation between JRuby and dyn.js, or JRuby and Rhino, or whatever. All the languages that implement this protocol will benefit from all the GIT that JVM has, the just-in-time compiler, and all the inlining, even between languages. We are starting to cross the bridge between the languages, and shorter this gap, so we can get lots of performance. When? How much time I have? 5, that's great. dyn.js is being released now. I just will do the push. It's open source as it should be. I am licensing it now under an Apache permissive license, so do whatever you want. It's a little better than the WTP. That were licensed that the guy talked before. So that's it. The current status. dyn.js is a beginning project. I do the most part with a friend, Alexandre Porcelli, a very smart guy. So we are walking slowly. It's nowhere near to complete. I'm even struggling to have something working on that. But it's huge. It has a lot of potential. And I need to remark something. I was talking on Brazil JS conference that happened in Brazil this year on March about this project. And 3 months later, we'll have the same idea, the big fat oracle. So I might be on something. Don't you think? The current status, what works and what won't work. We have an ES3 grammar, because we wanted to go straight to the 6, but it was not so well defined. So Brendan helped me when he talked, we're getting there. So we probably will move to ES6 soon, very real soon. We have a partial AOT compiler, so every time you create a function, we straight compile it to bytecode. So you will have a little overhead when you start your program, but for long-running applications like Node-like stuff, you will be in a better spot because the JVM will take care of much of the optimizations you can do. We have this auto-boxing stuff, so I can pass a primitive to a method that receives the number instance, and vice versa, and whatever. And we started to implement the Boolean stuff that you can if, string, and get some results like that. We have the prototype chain working too. Closing this talk, why did I do dyn.js? Because I want to have fun. Believe me, if you are not making things worrying, I know we have works that sometimes we need to do things that we don't like, but we need to try. After all, usually we are done working only for money. We are working because we like to program, usually. If you don't, I truly recommend it will make you a better person, a better programmer. And second, learn something new. Never stop learning. I wanted to use good abstractions, and I learned a lot on the process. Keep it simple. I get myself trapped on my own big up design front. So I need to basically rewrite from scratch 2 times. That's learning. And finally, why not make beautiful code? That's the whole idea. So there's one more thing. We have a repo. So let's see if I make it to be readable. Does anyone knows where the transparency is? Sorry? Oh, thank you. So the results from dyn.js compilation is that dyn.js all the jar. So I just run this. And we have a nice help telling us we have a repo. And this repo shows us what's happening under the hood. By now, we are on the development phase, so we have debugging info being split all over the console. So I can make something fun. Do you remember the code that I talked before, the stupid var cheese equals 1? Let's do it. Looks like what it did for us. That's the idea. I have a disassembled dump of bytecode. So we did assign the variable, but let's print it. So that is it. I hope you gotta love this project. It has a lot of work to do yet, but I can see the potential, because when you try to be careful about having a more clean code base, you can have more contributors, you can get people to understand what's happening, and everything wins. Everyone wins. So that's it, people. That's all. Thank you. Any question?
How much faster it is to write?
I don't want to even talk about performance now, just because. Have you ever seen that I didn't put performance on my main goals? The idea is you need to make it clear. We often, Charlie Nutter, a guy I admire a lot, told me one time that if I want to make Java, faster Java code, I should write C code on Java. So that's the idea. We are trading off, for now, buildiness and clearness for performance. But this thing will change, because the JVM are making tons of work that I wasn't doing, that people from Rhino were doing themselves. So things tend to improve. On the general code that was simpler and clearer, run about 4 to 8 times faster on JRuby. So that's no reason that we couldn't get this benefit here too. So I will worry with performance after we get spec compliant. That's the idea. Any questions? So thank you.
I have one more question.
Okay.
Is this a full free time project or?
Full free time. I have some friends helping me on this thing, and I hope we have got more contributors now.
Great, thank you.
Thank you.